Hi everyone, welcome back to my channel. So in today's video, we are going to solve a question that is based on maximum subarray, that is basically the Kadane algorithm. So first of all, let's see what question says. So we have been given an integer array in nums and we have to find a subarray with the largest sum, and obviously we have to return that maximum sum. So first of all, let's understand what is the difference between the subarray and subsets. We usually get confused about it. So in subarray, we have to take the contiguous elements of an array, right? But in a subset, we can skip or we can take either of the option. We can go for them. But in subarray, the elements have to be contiguous, right? So if I take this example, let's say, so we are also going to perform a DryRun. But first of all, let's think what comes to our mind, the very first approach. Like we have to get the maximum sum subarray, right? So what we can do is we can fix to a particular index, like let's go to this board. Now we can fix a particular index. Let's say we are fixing this to 5, right? And we can try different combination with 4, with -1, and then with 7, then with 8. Like we'll try adding them on. And then similarly, we are going to fix the index on 4, and then again we are going to combine it, like we are going to add -1, 7, and 8. So in such a way, we are going to get different combinations of sums, and from there we can also get our maximum sum. Okay. But if you're going to follow that approach, that obviously that's going to like take a lot of time, obviously because of n square complexity. So we have to cut down our time complexity to an optimal one, right? So for that, we are going to study about the Kadane algorithm. So what happens in that? Kadane's algorithm will not tolerate the current negative sum. I tell you why. Because our main approach is, our main target is to get the maximum sum. And whenever the current sum is going to be negative, it's nowhere going to help us to obtain the maximum sum. Okay? So then and there, we're going to set the current sum to 0. For an example, let's say, okay, so let's do the dry run for this approach. Like this is basically, I'm going to explain the Kadane algorithm using this example. So at first, let's say we are at this index, right? We'll be having two variables over here. First one is maximum sum, second one is the current sum. The maximum sum is going to store our absolute maximum value, and the current sum is basically at each and every step, whatever elements we are getting, we are going to add on into it. Okay, so we are at 5 here. And initially, I have taken maximum sum as int min and our current sum as 0. Now, the very first element we come across is 5. Now, we'll add on it to our current sum. So, our current sum is updated to 5. And similarly, because maximum sum is going to store what maximum sum is exactly, that अभी तक हमें जो भी maximum sum मिला है, that value is going to be stored within this. So, our maximum sum will be 5. Obviously, because 5 is greater than int min, so that's why. Now, next, our pointer comes to 4. Then our current sum is going to add on. Whatever is coming on the way, it's going to be added on into the current sum. So our current sum is going to be 9. 5 plus 4, 9. Then we are going to check that is 9 greater than the existing maximum sum. Then yeah, it's greater than it. So we are going to update our maximum sum as well. Okay. Now then we come to this -1, this index. Now again, whatever is coming here, we are going to add on to current sum. So our current sum will be 9 minus 1, that is 8. Okay. Now again, we are going to check that is the existing maximum sum less than the current sum? No, it's already greater than it, so no need to update the maximum sum. Now we'll move on to the next index, that is the number is 7. So again we are going to add it on to current sum. It's going to be 7 plus 8, that's 15. Okay, that's 15. Now again we are going to compare that is the existing maximum sum, is it less than the current sum? If it is less than, then we are going to update it. So this is basically the statement which we write, like maximum sum is equal to max of existing maximum sum comma current sum, right? That we're going to get it while writing the code. So this is also going to be updated to 15. I'm extremely sorry for the writing. I'm not able to write it properly. Yeah, it's 50. Now again, we're going to move our index and we're going to get the number 8. Again, we'll be adding it on to the current sum. This is going to be 15 plus 8, that is 23. Now again, we are going to compare if the existing maximum sum, if it is less than the current sum or not. So it is less than it and we can get more, like, more sum. So we are going to update our maximum sum with 23. Okay. Now till here we have reached the end of the array and we are getting the maximum sum as 23, and this is going to be our final answer and we have to return it. So let's go to the code and we are going to follow the same approach, whatever we did in the dry run. We're going to do exactly the same thing, same variables, and everything is going to be same. So first of all, I'm going to take a variable as we took there. First one is our current sum. Let me check I'm recording it or not. Yeah. Current sum, this is going to be 0. Then I'm going to have our max sum, which is going to be initialized with int min, as we did here, exactly the same way, right? And then there also we traverse the entire array, each and every element one by one. So even here I'm going to traverse the entire array. For int I equals to 0, I less than num stat size, I plus this. Okay. And then whatever element we are getting here, we are just going to add it inside the current sum. So we'll be doing here current sum plus equals to num stat 5. And then after this, we are going to update our maximum sum. Like after adding the element into the current sum, we are going to check and we are going to update our maximum sum so that we can get the maximum possible sum. Max sum is equal to max of max sum comma current sum. And after updating it, we are going to check the most important condition, which we can say it's the heart of the Kadane algorithm. We are going to check that, okay, we added something to the current sum. We also updated the maximum sum. After this, we are going to check that the current sum which we got till here, was it negative? And if it is negative, we are going to set it to 0. Because a negative current sum is nowhere going to help us to obtain the maximum sum for the further steps. So that's why I'll be checking here if current sum is less than 0, we'll set it to 0. Because somehow the 0 current sum is far better than having the like negative current sum. Okay. Return the maximum sum. So we initialized it with 0, current sum with 0, maximum sum with int min. Then we traverse across the array. We kept on adding the array elements to the current sum, and we were updating the maximum sum as well. And along with it, we were also checking that if the current sum is going to be less than 0, we were setting it to 0. And then we're returning the maximum sum. Let's run this code. Okay. Accepted. And So code is submitted successfully. Now let's see its time and space complexity. The previous brute force approach, if we would be trying that, then it would be taking approx big of n square time complexity. But here we are having only a single loop, okay? And we're not even taking any extra space as such. So it's going to take our big O of n time complexity and big O of 1 space complexity. So this was all about this video. I hope you guys understood whatever I tried to explain. So, okay, bye. Thank you for watching.